starting at 1. Okay, why is this starting at 1? Why? How come this one starts at 1? Can you explain to me why? Because when x is 1, right? When x is 1, y is what? 0, correct? That's why it will cut here. Understand? That is when a is bigger than 1. Now, what is the shape of the same? Sorry, not a, x. When a is between 1 and 0, it will go the other way, but it will still cut at 1. Is everyone clear here? Okay, now I will show you the various different graphs. You look at the board, I will show you the various different graphs. Okay? No need to take down, no need to take down, because ultimately it will be there. Okay? Y equals to graph here. Can you see it? Can you see it? This one is when this is the graph of I'm going to bring down this part. This is the graph of y equals to log 2x. This is the graph of y equals to log 2x. Now, can you see it cuts at 1? Okay. Do you agree that when x is 2, I will get 1 for y? Yes or no? Log 2 is 1, right? So, can you look here? Can you see at 2, you will get 1? Alright. Then it must cut at 1 because log 2, 1 is 0. Do you understand? Okay, now let me show you another graph. Okay, let me show you another graph. Can you look at this? The white one. This is the graph of y equals to log 4x. What do you realize? The shape is the same, right? Can you see the shape is the same? But can you see it's lower? Can you see it's lower? Why is that so? But it still cuts at where? 1. But when x is 4, then it will be 1, right? Correct. Can you see 4, 1. That's why it's lower. You understand what I'm talking about? Yes or no? So can you see that when my a is bigger than 1, I will always get this shape. Everybody can or cannot? Can, no problem. Okay, good. Now, then I want to look at another graph. This is y equals to log x. The red one is y equals to log x. Log x is actually log ex, right? When this is 1, this is 0. Can you see it still cuts at 1? Okay? This will be e, right? For it to be 1, right? You know that e is about 2.7 something, so right now? Okay, you look here. When it's 1, can you see it's about 2.7 something? Can you see what I'm talking about here? Okay, so what is expected for you to label when you sketch this type of graph? You'll be like this. This is what? Okay, this one must write out. Okay, and then what is this value when this is what? For example, when this is a y equals to log 5x, what do you think this is? What is this value? Can you see it must be 5? Can you see what I'm talking about here? Yes or no? Okay, let me change again. What if this is Okay. They did not capture what this is. Never mind, I'll do it again. Can you see the yellow one? Can you see it goes this way, it cuts at 1, right? Now, I'm going to change the scale for you to see. Wait, just a minute. Okay, I have shifted it this way. Can you see the red one is non-X? The yellow one, can you see it cuts at 1? Now, when it is 10, then it will be 1, right? Can you see it? That will be a log 10. Understand? Okay, now, can you see that log 10 is actually lower than your non-X? Can you see it? Log X is actually lower than your non-X. Correct? Everybody clear? Can already? Okay, can. So, do you understand this one now? Yes or no? This shape, okay. Now, I'm going on to the next type of graph, which is the other way. Okay, and I'm going to show you. Now, can everybody look at this? Okay, can you look at this? Can you see it's the other way around now? Now, this is the graph of. What's my answer? This is the graph of y equals to log half x. Understand? Now, when this is 1, it will still be 0, am I right? So, can you see it still cuts here? Yeah? Now, when this is half, if I have log half, oh, I get 1, right? Now, can you look at half? Half is here. Can you see it has is at 1? Everybody okay now? Do you understand what I'm talking about here? Can, no problem, So it goes this way, okay? Now I'm going to show you one more. That is y equals to log 1/4 x. 1/4 x. Okay. Can you see it will be the same way? Can you see it goes here like that? But the same shape. Can see it cuts at 1. Now is when it is 1/4 is at 1. Can you see it? Can you see? When it's 1/4 is at 1. Okay. Now why do I want to show you the various shape? Because the text will only show you one type of shape. It doesn't show you a lot of other shapes. Everybody clear with what I'm saying? Yes or no? Okay. Alright, now next thing that I want you to take note is this. Okay? Can you look at the next page? Page 125. Okay, 125. The diagram shows the graph of y equals to ex and y equals to ln x. Now, can you see that they are symmetrical about the line y equals to x? Can you see it? What do you mean by symmetrical about the line y equals to x? That means y equals to x is the mirror line. Understand? It reflects about y equals to x. Okay, now, I just show you here. I'll just show you one more. Then I will arrange this thing. Y equals to. Can you see this is y equals to ex? Can you see it passes at 1, right? Okay. Now I'm going to do y equals to ln x. Now can you see it's the other way around? Can you see it's here? And the line of symmetry is actually this line, y equals to x. Everybody clear here? Yes or no? Yes or no? Now, this is the equation of y equals to ex on the graph. This is equals to y equals to ln x. And it's reflected about this line, y equals to x. Can you see that? That is the line of symmetry. So that is your page 125. Are you okay so far? Are you okay so far? So, I'm going to repeat this one last time, and then I'm going to close it already. First part, you have like that, right? Correct. Like that means y equals to log ax, where your a is bigger than what? 1. Okay. Next one, you have this way, it also cuts that one. This will be y equals to log ax, where a is between what? 0 and 1. Understand? Can or cannot? Can or cannot? Can, okay, then the important one is on page 125. Ex and log x, they are mirror image of each other about the line y equals to x. Are you clear? Okay, good. Alright, then I can start my work already. So this is done. Can all of you now look at example 25 on page 125, example 25. On a separate diagram, sketch each of the following routes. Okay. Now, exam will also ask you to sketch. Don't think that only we sat down to ask you to sketch. Exam will also ask you to sketch, okay? So, let's look at the first one. You will have the axis like that, and you will go this way, and you label this one 1 first. Understand? This will be y equals to log 3x. Okay? Now, other than 1, I want you to label one more thing for me. When it is 3, what is this? It's 1. Can you add this into your diagram of page 125? This is the graph of y equals to log 0.5x. Now, 0.5 is what? Half, right? It's between 0 and 1, right? That's why it goes this way. It's at 1. Now, that means log 0.5 will be 1, right? Yes, yes. That means at 0.5, this thing will be 1. Can you also add in this point here on your graph on page 125? Are we okay so far? Are we okay so far? Yes or no? Yes, okay. So, basically, right, for today, I've gone through all the curve sketching already. Understand? Like that, and then like that. No? Must remember. Don't forget this one. Last time we learned, this one also must remember. Cannot forget. Understand? Then I want to ask one question. Is this a straight line or a curve? Straight line. How come some of you draw a curve? Because I do not understand. How will this line look like? You tell me. What's the gradient? Negative, right? What's the y-intercept? How will it look like? This way, right? Sometimes there's some people drawing this way and then some people drawing this way. Is it a curve in the first place? You know there's something called ruler. That's why you must bring a ruler. Is that clear? And let me just remind the whole class. When is your index WA2? Next week, next month. Wednesday. Next Wednesday, right? Which chapter? 3, 4 until 5.4, right? Until before the applications, right? What must you bring for the test? Flexible ruler and the bench first, right? You must bring your pencil. Don't draw with blood. Do you understand? I don't have a pencil, I don't have anything, I'm going to draw with blood. Okay, I don't want to be accused of telling people to do this. Okay? Oh? Okay. Now, next part. What are the applications of log functions, okay? Alright, let's take a look at applications of log functions. Grade 1 to 6. Logarithmic scales are commonly used in science, economics, and engineering. For example, the Richter scale and the Roman magnitude scale that replace it are logarithmic scales that illustrate the strength of an earthquake. I think you know those who do geography. In physics, the decibel is a log unit quantifying sound intensity. In chemistry, pH, I think you know pH scale, right? Okay, is a log measure as well. Okay, now let's take a look at example 26. Alright, I think most of it I can only stop at example 26. Example 27, the last one. Yeah, so I must not do everything, and then after that I set you the homework. Tomorrow when I'm not around, you will do it. Will that be okay? These are the... I'm a bit very tired. It's not because I'm tired of the listen to me, it's because it's your future you're going to listen to me. I got all my A's already. It's your turn. Understand? Okay? Your certificate will say your name. You will not say top by your name. Do you understand? This is ridiculous. My name will never appear on your cert. So, okay? Alright, let's take a look at example 26. Chemistry, pH. The scale for the acidity of a solution. The pH given value is given by the formula. Okay? pH equals to negative log 10 H plus, where H plus is the hydrogen ion concentration in moles per liter. Okay, I don't know what I say, but never mind. Just continue, okay? Alright, now, tomato juice has a hydrogen ion concentration of 0.001 mole per liter. What is its pH? Okay? Now, what is its pH? Okay. That means part 1, you're supposed to find the pH of the tomato, is log 10, 0.001, right? Correct. I'm talking to you. Okay, now. The hydrogen ion concentration is this, right? Now, some people don't know how to do this, so they will key the calculator. It's also okay. It doesn't matter, but I want you to look at this. Do you agree this is 10 to the power of what? 1, 2, 3. This is 10 to the power of negative 3, right? Am I right to say that? Do you agree it's 10 to the power of negative 3? Those who cannot now, go back to basic. This is 1 over 1000, right? So this is negative log 10. This is 10 to the power of negative 3, right? Can you see it now? Hey. This is 10, 3, correct? So negative 3, correct? So what's the pH? Negative 3 log 10, correct now? You bring down the negative 3. What's log 10? What am I talking about? Log 10, yes. What's log 10, 10? 1. So what's the pH? 3. Everybody clear? So the pH is 3. Look at the next page. The pH of the tomato juice is 3. Everybody okay here? Are you clear? Are you clear? Okay, now next. The pH of lemon juice is 3.5. What is hydrogen ion concentration in mole per liter? Give your answer in scientific notation. Now, scientific notation means standard form. Scientific notation means standard form. Okay, so don't be confused by that. So we will have 3.5 equals to negative log 10. Like this, right? I'm supposed to find this one. So what do I have here? I will have log 10 equals to negative 3.5, correct? So this one will be what? Am I right to say that? Okay? Use your calculator, key this. What is this? 10 to the power of negative 3.5. I want to key this. What is this? 3 significant figures. You will tell me, Cher, you already said log 10 is LC, how come the question gives like that? If the question gives like that, you just follow the question. If not, you must use the short form, understand? Okay? Alright, last question. If the number choose in part 2 is diluted by a factor of 10, how would its pH be affected? Diluted by a factor of 10. Can you look at the next page? Okay? Now, can you see that they divide by 10? The concentration is divided by 10, right? Diluted means the concentration will be lower, right? So you divide by 10. Can you see that? I'm talking to you. Can you see that? Okay, so you divide by 10, you get this answer, then you get 4.5. Now, from 3.5 to 4.5, what will happen? What's the result? It increased by 1, right? 3.5 to 4.5 increased by 1. Agree, class? Yes or no, class? Yes or no? Do you know that the higher it is, it becomes alkaline? You know that? So that's why when we dilute, it must become more alkaline or less acidic. That's the thing. Everybody clear here? Can or cannot? Do you know what I divide by 10 over there? Can, huh? Okay, no problem here. Now, next part, example 27. This is the one that may have problem. Okay, I don't think I have enough time already. Can you look through example 27 yourself? Okay? Then tomorrow I will set up everything onto the SLS. You better go and take a look. I don't want people to waste my time tomorrow in class. Then after that Friday I have to repeat all over again. Is that clear to everyone? Yes or no? Yes or no? Okay, stop the video.